Hello students, so this is a question from graph algorithms and it is a 1 marks question. Okay, so let's read the question first. The weight of the shortest weight path from A to F in the graph given below is dash. Okay, so what we have to do, we have to find the shortest path, the weight of the shortest path from vertex A to vertex F. Okay, so this can be solved by using Dijkstra's single source shortest path algorithms. Okay, by using Dijkstra's single source shortest path algorithm. What this algorithm will do, it will finalize the distances. It will finalize the distances to each nodes. Okay, so let's see how it works. So A is the source here. This is my source. And I want to measure the distance from A to B, C, D, E, F and G. Okay, so we'll see first what are the direct edges between A and all other vertices. Okay, so what are the direct edges? A to B and A to C. So the distance from A to B and A to C is what? 5 and 3. Is there an edge to any other vertex? No, there is no other edge. That means the other distances we'll put as infinite. Okay, so this is the distance. Now from this distances we will choose the vertex which has the smallest distance. That means that is nothing but C. So we'll consider C now. Okay, so A and C. So we have finalized the distance to C from A. And what is that distance? That distance is 3 units. Okay, so now we'll see whether there are any edges from C. So let's check that. So there is an edge from C to E with weight 7. There is an edge from C to D with weight 7. That means the path from A to E will take how many units? It will take 10 units. So that we will change from infinite to 10. Similarly, the path to D is also 7. So 7 plus 3 is nothing but 10. So these two distances we have measured by adding C, and the other two are infinite. Similarly, now we'll pick the one with the smallest distance from B, D, E, F and G. Because the distance to C is already finalized, we have to pick one of the remaining vertices, which is B. B has the lowest weight, 5, 10 and 10. So we are considering B now. So let's consider the vertex B. Let's see the edges which are going from B. So there is an edge which is going to G, there is an edge which is going to E, and there is an edge which is going to C. But the distance to C is already finalized, so we'll not consider this edge. But the other two edges we'll see. Okay, so there is an edge with weight 1. That means the path from A to G has weight 6. So this infinite is changed to 6. Similarly, there is an edge with weight 3 from B to E. That means there is a path from A to E with weight 8. So because 8 is less than 10, we'll remove this number 10 and we'll convert this 10 to 8. So the distance from A to E via B is 8. Okay. Similarly, now we'll see the so the distance to B is again finalized. Now we'll again pick one vertex which has the lowest weight, which is nothing but G. So we'll consider G here and we'll find the distance from G to all other vertex. So there is an edge from G to E which has weight 1. So the distance to E will become what? See, the distance of A to G. Let's see, the distance of A to G is 6. Now there is an edge from G to E. That means the distance of A to E will become 7. Okay. Now let's see what is the distance here. The A to E distance is 8. And according to this path A to G and G to E, according to this path A to G and G to E, the distance is 7. So we'll update this distance from 8 to 7. Okay. So again the distance to G is also finalized. Now we'll pick one of these 3 vertex. So this is the shortest path. There is a shortest path from A to E. So we'll pick this vertex E and we'll include E also. And we'll check if there are any edges from E. So there is an edge to F with weight 1. So A to E is 7 and plus 1. So if we add one more weight there, that is 8, which is nothing but a path from A to F. Okay, so the distance from A to F is nothing but it is 8. So the weight of the shortest path from A to F is nothing but it is 8. And what is the path? The path is nothing but A to B, B to G, G to E, and E to F. So this is the path: A to B, B to G, G to E, and E to F. Okay. So this is the final path or the shortest path, and the weight is 8. Thank you.